So today we're going to be talking about slip and slide method. What slip and slide method is, it's a way to factor a trinomial that has a leading coefficient, the number in front, that's greater than 1. So when you first start factoring out trinomials, typically you'll see something that looks like this. The leading coefficient here, so the term that's in the very front is just 1. 1 is in front of x squared. So when you go to factor this, and from previous videos, you'll hear me say build the skeleton. We're going to put x and x. I go to the second sign second, which tells me the signs are the same. All I know is that they're either both plus plus or both minus minus. And figure out which one it is by looking at the first term. So they're both positive. And then I'm going to ask myself, what are factors of 20, the constant, that sum up to the term in the middle? And if I went over here and listed factors of 20, I have 1 times 20, 2 times 10, and 4 times 5. So which set of factors, which pair, is going to add up or sum up to 12? It's going to be that 2 and 10. And it actually doesn't matter if I put 10 first or 2 first, because both of the signs are the same. So that's what you'll hear me refer to as a very basic example of factoring. But what happens when you have an example like this one? 2x squared plus 5x plus 2. So the first thing I want to do, no matter what I'm doing, I always want to check for a greatest common factor and see if I can factor anything out. When I take a look at this trinomial here, the GCF is 1, so there's not really much I can do. But what's different than the first example, the one I was calling basic, is I actually have a leading coefficient that's greater than 1. In this case, it's 2. So I need another method or a different approach to how to solve this, to actually factor my trinomial. What I'm going to use is, I'm going to use what's called slip and slide method. And slip and slide works like this. I'm going to slip the leading coefficient into the constant. And slip means to multiply. So I'm going to rewrite this as x squared plus 5x plus 4. I took the leading coefficient and I multiplied it into the term at the end. And what that revealed is something that's now basic. It kind of looks like the example I did previously to the left. Now I can easily build the skeletons of my trinomial. I'm going to use x and x, and I'm going to go to the second sign second. If the second sign is positive, I know my signs are the same. And I'll refer to the first sign that positives know they're both positive. Now, just like the one before, I'm going to ask myself, what are factors of 4 that are going to sum up to 5, my term in the middle? Not 2 and 2, but 1 and 4. And it actually doesn't matter where I place 4 or 1 because the signs are the exact same. Now, what's different about slip and slide is I'm not just done here. I did slip, but where does the slide come into play? I always help remember this by slide rhymes with divide. So I'm actually going to come back through, and the thing that I slipped, the leading coefficient, I'm going to slide it back through to both of these terms. Now, when I'm looking at these next pieces, I have to ask myself, are they fully reduced? So when I look at the first term, that 4 over 2, I could simplify that to just x plus 2. That 4 divided by 2 is going to yield 2. Now, when I look at the second one over here, I have to say, is this fully reduced as a fraction? Is 1/2 in its simplest form? And in this case, yes. Now, an example I'll do later, we may have to actually reduce it. So if I got something like 5 over 15, I would need to make it 1/3. But in this example, 1/2 is fully reduced. If I decide that it's fully reduced, I'm going to take my denominator and slide it up to make it the new coefficient. So what this is going to yield is 2x plus 1 and x plus 2. So let's actually take a look at 2 more examples when you use slip and slide method. So when I look at example number 1 on the left, the first thing I'm always going to do on both of these problems is check for a GCF. Now, when I examine each of these pieces, the GCF is 1, so there's not really anything I can factor out of there, which means that my leading coefficient is still greater than 1. Therefore, what I want to do is use slip and slide method. So I'm going to slip the leading coefficient into the constant. Again, slip means to multiply. So I'm going to rewrite it as x squared minus 11x plus 30. Once I've gotten here, what I'm doing is building a very basic trinomial, something that's easy to factor. I'm going to build the skeletons of this, splitting up that first term, x squared, into x and x. The second thing I want to do is go to the second sign. Because the second sign is positive, all I know is that the signs are the same. Either they're both plus plus or both minus minus. Well, how do I figure it out? I actually look at the first sign. So in this case, they're both negative. I can fill in the skeletons of my trinomial. And then I'm going to ask myself, like I normally do on a basic trinomial, what are factors of 30 that are going to sum up to negative 11? So I'll just start by listing all the factors of 30 that I can think of. 1 and 30, 2 and 15, 3 and 10, and 5 and 6. So which pair of factors is going to sum up to negative 11? And as I go through my choices, I'm going to get down to 5 and 6. Again, it doesn't matter if I pair the 6 or 5 first because both of the signs are negative. At this point, we are halfway there. That's not your answer because so far you've just done slip, but you still have to slide. Now, slide means to divide. I'm going to come back through and use that piece that I slipped in front, and I'm going to divide it by both of my terms. So when I'm looking at these pieces, that 6 minus 3, that can just become x minus 2. I'm just asking myself, what is 6 divided by 3? On the piece to the right, I just have to make sure that this fraction is fully reduced if I can't just simplify it right away like I did. 6 over 3 becomes 2. So in this case, 5 over 3 is fully reduced. Now, even though the fraction is improper, we don't care about that. It just has to be fully simplified. If I decide that it's fully simplified, that 3, the denominator, is going to become your new coefficient. And now I've completely factored the trinomial. Let's do the same thing for the example over here on the right, number 2. I'm still going to check for my GCF first, but it looks like the GCF is 1. There's not really anything that I can take out of or factor in this trinomial. So because I have a leading coefficient that's greater than 1, I'm going to use slip and slide method. I'm going to slip that 8 into the 9, the constant at the end, and slip means to multiply. So I'll rewrite it as x squared minus 6x minus 72. And again, there's my basic trinomial, something that you really start off learning how to factor. So I'll build a skeleton. I'm going to use x and x. That's coming from taking x squared and splitting it in half. X times x is going to give me x squared. And then I'm going to go to the second sign. When my second sign is negative, I know that my signs are different. So I can go ahead and build the skeletons as one being plus and one being minus. Then I'm going to ask myself, what are factors of 72 that are going to sum up to negative 6? So I'll start with 1. 1 and 72. 2 and 36. 3, we could go to 4. We could go to 6. So 4 times 18. We have 3 goes into that 24 times, and 6 goes into that 12 times. 8 is also going to go into it 9 times. And now I've listed every single one of my factors. So looking through the pairs, which combination is going to sum up to negative 6? It's going to be that 6 and 12. When you have signs that are different, now if you look back over the example on the left, when my signs are the same, it doesn't really matter where I put the 6 and where I put the 5. But in this example, choosing 12 and 6, it does matter because I want my factors to add up to negative 6. So the question is, where do I put 12 and where do I put 6? Do I put 12 with the positive and 6 with a negative, or 6 with the positive and 12 with the negative? If I want them to add up to negative 6, I'm going to have to put the 12 with the negative and 6 with the positive. Because when I sum those two together, that's going to give me negative 6. But so far, I've still only done slip. I still have to slide and divide. And whatever I slipped into the front, this time I'm actually going to slide that 8 back through. So when I'm looking at these pieces, just as I did before, I have to ask myself, are they fully simplified? When I look at 6/8, that can actually be reduced to 3/4 as a fraction. And my term on the right, 12/8, can also be reduced, that can be reduced to 3/2. Now that I have fully reduced these, I can take the denominator and slide it up to become the coefficient in both of these examples. My final factors are going to be 4x plus 3 and 2x minus 3. Now I factor the trinomial. If I want to see if either of these answers were correct, I could always FOIL it back out or use box method and see if I produce the original trinomials. In both cases, I will. So again, slip and slide is a very great method if you have a leading coefficient that's greater than 1 after you have checked for a GCF. It's a way that makes it a little bit easier by creating those basic trinomials, letting you slip the coefficient and then slide it back through, slide and divide to fully factor the trinomial.